All right, here we go. Homework. All right, today's class is on the volume and the surface area of pyramids. Okay. Well, let's recall back from the chapter we had on polygons and apply the definition of a triangle to a three-dimensional version called a pyramid. So a pyramid is a polyhedron, 3 dimensions. It's going to have a polygonal base. That means the bottom of the pyramid could be any polygon. Yes, we like them when they're squares, but they could be actually any shape to include a triangle. The difference between a pyramid and a prism is the sides are not parallelograms. The sides will always be triangles. Remember back the chapter on polygons with triangles. So the sides are only going to be triangles. Those triangles all come together and they meet at a point at the top of the pyramid. The base is a polygon. Remember, anything. You're going to see lots of weird ones today. Sides are triangles. So the parts of the pyramid. So look there. The base is looks like a home plate on a baseball field. That is a pentagon right there. So that's a pentagonal pyramid. We don't see those too often. So let's see. You got the base. Once again, it's made of a polygon. Second thing you have is the sides. We call the sides, just as we do on a prism, we call them lateral faces, and they will be made up of triangles. And then lastly, all those lateral faces meet together at a point at the top. We call it the vertex. Makes sense. And the last thing is the distance between the perpendicular distance between the base and the vertex is called the altitude, just like it is for a prism. Yes, we'll interchangeably use the word altitude and height. All right, here is a hexagonal pyramid. We have one extra word that we're going to throw in. Now, I did not draw it on that pentagonal one. There is one there. I just chose not to draw it. If you notice there on the hexagonal pyramid right there, we get an extra little red line right there. It's solid. And it's labeled lowercase italicized L. That is the perpendicular distance between the base edge and the distance to the vertex. And notice it's kind of slanted, which is why we call that one the slant height. So I always say, imagine yourself walking up the side of a pyramid. You probably wouldn't want to walk up on the spine. You'd probably walk up on the lateral face portion of it, not an edge. And that would be called, and the distance you would walk would be called the slant height. All right. There are just like, remember I said when we do this for prisms, there's basically two main types. Regular pyramids will be when the perpendicular distance, that height there is measured from the center of the polygonal base to the vertex. So therefore it would form a right angle. And if we move the vertex left or right, we get our oblique pyramid. We will get no formulas for oblique pyramids. All of our formulas will be for regular pyramids. So let's look at those regular pyramids. The bases, once again, are a regular polygon. We had that from the previous chapter. Remember, regular polygons are polygons where all the sides have the same measurements and all the angles have the same measurement. The lateral edges, right, are all congruent. In other words, those black lines right there that join the triangles together, they are all congruent. Notice that would not be true for the oblique pyramid. All the lateral faces are isosceles triangles, and I should say, it does say congruent isosceles triangles. And lastly, the altitude goes to the center of the base. Notice that's none of those are true with the oblique pyramid. Okay, so the first game we're going to play, and it's the same games for every shape we do. It's going to be calculating the surface area or total area. And the second game is going to be the volume. In order to calculate the total area or surface area, we may, or I should say, we will need to have the distance called the slant height, that little L. There's two main methods, and the two main methods for calculating slant height just depends upon what information you are given on your specific pyramid. All right, so here's the first one. So let's say you're given the lateral edge. All right, that's that 13 distance right there. And let's say you're given a base. In this case, we're told that the base dimension is 10. So I'm given a lateral edge and I'm given a base. I'm like, well, there's some other numbers there. There's a 5. We'll think this one through. Remember, we're only going to be dealing with regular polygons as the bases and regular pyramids, regular or right pyramid, sorry. So it's a regular base. So that means it's a square. And therefore, we said that isosceles triangles, congruent isosceles triangle, make up the faces. Therefore, that's where that 5 and 5. Half of 10 is 5. Okay, cool. So I'm trying to calculate the red lowercase italicized L, the slant height. There's lots of triangles right there. There's that yellow triangle right there. Let's see, how many dimensions do I know of that yellow triangle? Because that has the slant height, the L. Well, I only know one of them, 5, and I can't tease out that information. So I need another triangle in order to calculate that L. And if you notice, for that particular one, I'll make it in blue, this one lateral face right here, which we were told, since it's a regular pyramid, a right pyramid, sorry, that's an isosceles triangle. So if I pull that triangle off to the side right here so I can see it a little bit better, I'm trying to get that red dotted line right there, right? Because that's the slant height. We know the base is 10, so half of 10 is 5. And now notice I have two sides of a right triangle. Therefore, I can calculate the third side by using Pythagorean theorem or recognize that particular one is a 5, 12, 13. Pythagorean triple. So let's see, L squared, that's the red dotted line I'm trying to calculate. Plus 5 squared is equal to 13 squared. Just do a little bit of algebra right there. Take the square root, and we get 12. So I now know the slant height was 12. So if you are given the base edge and the lateral edge, or the lateral face edge right there, then it's a simple yank off one of the triangles, it's isosceles, do a little bit of Pythagorean theorem, and that would solve it. So that's kind of like a case number one. Case number two, let's see, what am I given? I'm given the height of the pyramid, 12, and I'm given the, once again, a base edge of 10. So now I'm going to actually calculate that yellow triangle right there. And then once again, it's a 5, 12, 13 triangle. It's still the Pythagorean theorem. So I guess in essence, for both techniques, it all boils down to the Pythagorean theorem, but it does mean you need to choose the correct triangle to calculate the slant height. Key tip here is that use the triangle that has 2 bits of information. One of the triangles will only have 1. Notice here, if I were to use an isosceles triangle, I would only have the distance of 5 or 10 for the whole thing. So I would only have 1 measurement, whereas on the yellow one, I have 2 measurements, the 12 and the 5. All right, so in both cases, I'm still just doing the Pythagorean theorem. So I get 13. All right. So the second thing, let's see, I've calculated the altitude, or I've calculated the slant height. Now we're going to calculate the altitude. So once again, there's lots of triangles there. I simply need to pick the triangle that has 2 values in order to calculate the one that I want. And if you notice right now, I kind of have a conundrum. The yellow triangle has a 5, a height and a slant height. So I would need to first calculate the slant height, which is why we just did all that work in the previous 2 problems. So in order to calculate the altitude there, I might have to calculate the slant height. Notice I couldn't use the lateral face right there. That wouldn't get me anywhere to calculate h, but I will use that in order to calculate the slant height. So in essence, I guess I am. And notice the yellow triangle right there. I have 2 unknowns, the height and the slant height. So I need 2 values in order to calculate the height. So in other words, I need to calculate the slant height. So I'm going to go back to the previous one that I don't draw it right here, that blue triangle. Let's see if I can draw it real quick. Yeah, here we go. So I'm calculating this triangle right here. So if I draw that right here, there's my slant height, this L. I'm going to use a cursive L. Cursive L right there. I know this side is 5. I know this side is 13. So I'm going to calculate the slant height using that. Okay, so it's Pythagorean theorem, so we get the slant height is 12. Toss that back into my original equation there, upper left for slant height. That would be your 12. Oh, I actually did draw that triangle. Look at me. Let me clear out all that mess so you can see it better. There we go. Okay. So I got a 5, 12, 13 right there. Wait, it's not a 5, 12. Oh, I see what I'm doing. All right, correction. So I found that the slant height was 12, And now I'm showing that I'm drawing that yellow triangle out to the side here. Sorry for the confusion. So I'm drawing that yellow triangle out to the side here to explain it a bit more. And that is not a 5, 12, 13. The previous one was a 5, 12, 13. This one has a hypotenuse of 12, so I'm going to throw those in. So for my values, 144 minus 25 is 119. So it's the square root of 119. That's not a pretty answer. So that is my height, the square root of 119. There are no perfect squares. If you were actually trying to cut a piece of wood to that dimensions, then we would use the approximation symbol right there. So take the square root of 119. The book will not ask that. It will simply say, what is the exact answer? So the square root of 119 is your exact answer. 10.9 is your approximate answer. All right. Let's see. The next game, well, the ultimate game, right? Recall from last class, the two main ideas, and I've said it before this class, is surface area or surface area or total area and volume. And total area or surface area is calculated by the lateral area plus the base area. So the lateral area would be the area of all the sides, all those isosceles triangles added up together. And the cool thing is for a regular pyramid that we wrote down on a previous slide is they're all equal, right? It's the area of all the triangles, right? So let's see if we can come up with a nice, easy formula for that. So one of those triangles right there, there's one of them, and we've already done this, right? To calculate the area, we need base times height divided by 2. We already figured out previously that the slant height was 12, and the area is base times height divided by 2. So the base is 10, the height is 12, divided by 2 is 60. And let's see how many of those triangles we have. We have 4, so 4 times 60 would be 240 square units. So there's your lateral area for that particular triangle. And I'll just point out that once again, that slant height, we needed that particular dimension in order to even do this calculation. So even though slant height doesn't seem to be that important part of the entire pyramid, it ends up sneaking into almost every formula that we do in some form or fashion. All right, is there an easier way? Yep, there is. Let's try to tease this out. Well, we know that we need to calculate one of those triangles as the starting point. That's how we started this calculation. So that would be, I'm going to sneeze here for a second. Excuse me. We know that the lateral area is base times height divided by 2. So that 10, where did it come from? It came from the base of the square at the bottom, right? And then ultimately, we're multiplying by 4 because there's 4 isosceles triangles. And if you think that through, we're eventually going to be multiplying by 4, and 10 times 4 is 40, and 40 is the perimeter of the base. So in other words, we could shorten this formula by changing it from not base times height divided by 2 times the number of triangles, but we could change that to perimeter times the height divided by 2. And if you notice, 12 was the slant height. So hey, I can change that H to an L, and then divide by 2 is divide by 2. So this is a much easier formula to use. PL divided by 2 is your lateral area. And this is actually a theorem, by the way, we just proved that. This is a theorem 12.3 that says that the lateral area of and this is only for a regular pyramid, and that's the only ones we're going to give you, is PL divided by 2, where P is the perimeter and L is the slant, that darn slant height. Here it comes again. Okay. The but here is that we always want total area, and our book does not give us this formula, so I'll give it to you. If you think about this, if the lateral area are the sides of a pyramid and the base is the bottom of the pyramid, it would be total area would be lateral area plus capital B, or base area. Remember, capital B doesn't mean base, it means base area. So lateral area is PL divided by 2 from the previous theorem. So the final formula, the one to remember for total area, is PL over 2 plus B. So I usually call this the theorem that's not a theorem, right? That one right there. All right, not a proof, but if you watch the video, let's see, he's putting 3 of something. Hey, he put 3 pyramids together and it made a cube. This is not a proof. But clearly, if you start off with, see, there are 3 pyramids. And look, the bases of those pyramids are squares. So if you start off with 3 regular pyramids, and we'll watch the video one more time. You start off with 3 of them and you put them together, it makes a perfect cube. So think this through. If 3 regular pyramids make one cube, that if you put them together and you're only trying to solve for one, then it would be the cube divided by 3, which would be the volume. And that is theorem 12.4, which is base area times height divided by 3. Because remember, there were 3 of them that made one cube. So if you take the cube and divide by 3, you get back to one of those regular pyramids. All right, capital B stands for base area. Height is your altitude of your pyramid. And 3 is 3. How about that? All right. You think I'm going to give you an easy example or a challenging example? Well, in 7th and 8th grade, they're all easy. And we did have this formula in 7th and 8th grade, but this will not be an easy one. So this is going to be a much uglier one. Let's see. We have a hexagonal pyramid, a height of 12 and a base length of 6. And it says calculate the volume. We've got a nice easy formula, right? UG, because it's not a square. If it was a square, this would be easy. Let's see, base area of a square would be 6 squared times 12 divided by 3, and you'd be done. But in this particular one, it's a hexagon, so we got to remember back to our formula for area of a regular hexagon. This was that question on the last test. And if you remember right, so I can throw the 12 and the 3 in there very easy. 12 divided 3 is 4. So the base area, we have that one formula, which is kind of hard to remember for all regular polygons. And this is only for regular polygons. The formula is, it's that one that we broke up into tiny triangles. Remember, it was AP divided by 2, where A was the apothem, P was your perimeter. All right, so let's see if we can do this real quick. Well, once again, you either remember or you can calculate. There's 6 of those triangles there on that hexagon. 360 degrees in a circle. 360 divided by 6 is 60. So that angle is 60. We know that the base side is 6. So the perimeter, 6 times 6 is 36. 36 divided by 2 is 18. So it's 18 times whatever the apothem is. So I got to calculate that red dotted line right there. Let's see, if that total angle is 60, half of 60 would be 30. So it's a 30, 60, 90 special right triangle with a side length of 3. So there's our special right triangle, 30, 60, 90. Remember, the side opposite 30 is always x. The hypotenuse is always double x. And the one that we want, which is the apothem, or the long side of the right triangle, is x root 3, or root 3 times x. And let's see, x is the value 3. So it would be 3 root 3. So x is the value 3. So 3 root 3 is that apothem. So I'm going to take 3 root 3, throw it back into my formula for the letter A. And it's not a nice answer, but it is the answer. 36 divided by 2 is 18, and 18 times 3 is 54. So we get 54 root 3, and that is just the base area. Remember our formula over there to the right. I just need to throw that in for the capital letter B, 54 root 3, and then go to town. 12 divided by 3 is 4, and 4 times 54 is 216. So final, I didn't put my units there. It should say cubic units. So don't forget your units like I just did right there. Bad form. All right, the worst one. This one typically is bad because it causes your eyes problems of just wrapping your eye around what's going on here. All right, let's see if we can do this real quick. So we need base PL divided by 2. The perimeter, there's no values there. Slant height, there's no values there. So the only thing I get from this formula is a 2. So somehow I have to tease all that information. This is a very challenging one. All right, so got nothing. I can't plug in anything. So I'm going to look at any of the right triangles that I have 2 values and see if I can do something. So I got 2 values on that particular right triangle right there. I can solve for the third one. Just use the Pythagorean theorem. All right, so 100 minus 36. 64, square root of 64 is 8. So that little tiny portion of AM is 8. So AO is the value 8. I still need the perimeter, and I still need L. Where am I going to get those from? Well, we got to reach way back for this. So look at that triangle right there. Notice I have the 6. That's the triangle I would need to calculate for the L, but I'm missing the bottom piece right there. So what am I going to do? I'm going to reach way back that says that if you have a line that goes to the midpoint of the opposite side of a triangle, that it breaks things up into parts 2/3 and 1/3. Boy, that's reaching way back. So 2/3 of AM would be equal to AO. And therefore, well, we know what that is because we just calculated it was 8. So AO was 8. And I can do a little copy dot flip there to get rid of the 2/3. So multiply 8 times 3/2, which would be 24/2, which would be 12. So therefore, I know the entire piece, AM, is 12. And if AO is 8, then that leaves 4 for OM. That was a lot of work. So now I can calculate that blue triangle there. I didn't say this one was easy. All right, so right triangle. So let's see, 36 plus 16 is 36, 40, 52. So the square root of 52. Let's see, 4 goes into 52 13 times. So 2 root 13. Yikes. So the slant height is 2 root 13, but at least I got the slant height, right? 2 root 13. So I now need to do the perimeter. I got anything for the perimeter? I got nothing, right? The perimeter is, oh, by the way, I'm just reducing that fraction. 2 divided by 2 cancels, so I'm left with P times root 13. So we're back to, hey, what is the perimeter? So I'm going to reach for that triangle right there. I know the slant height was 2 root 13. I know that all the edges are 10, so I can calculate CM there just by doing Pythagorean theorem again. So 10 squared is 100. 2 root 13 squared would be 4 times 13. Squaring 2 root 13 would be 4 times 13. 4 times 13 is 52. Subtract 52 from both sides, 48. Square root of 48. That would be 16 times 3, so that would be 4 root 3. So that's just CM, right? We just calculated CM. So if I doubled that, I would get to CB. Why am I doubling it? Because I'm trying to do the perimeter of the bottom. So that would be what? 8 root 3, doubled that side and that side, add together would be 8 root 3, and there's 3 of them. So I got to take 8 root 3 and multiply by 3 because there's 3 sides. So 24 root 3 is your perimeter. Yikes, throw all this together. Square root of 3 times the square root of 13 is the square root of 39. So I get 24 root 39 square units. Right, that's just my lateral area, by the way. And it says calculate the lateral area. It didn't say calculate, but this would be even more challenging to do volume. Okay, wow, indeed. All right, so the last one is the volume. We're not going to duplicate our work. We just found out the edge was 8, or the base edge was 8 root 3, which we need for my base area. Remember, base times height divided by 2 would be their base area. So let's see. The height was 6. 6 divided by 3 is 2, so 2 times B. And luckily for us, my base area is, we've already calculated it, so that would be 8 root 3. That's the base. That would be CB. Times the height, which is 12. We're doing the base area of the bottom triangle divided by 2. 12 divided by 2 is 6. 6 times 8 is 48. So 48 root 3. Toss that into my B. And it turns out the volume wasn't bad. Why? But it was bad because remember, we had to do all that work just to find the 8 root 3 in the previous problem. So this one ends up being an ugly answer, but an easy answer because we did a lot of work on the previous one. So this was more of a challenging problem, or challenge problem, just to show you it can be done. All right, so that's it for today's class. Remember, they're always going to throw a table in for you, but you're a pro at it now. You should be good at calculating those from now. As always, if you have any questions, don't hesitate to send me an email. You're doing great. I have complete confidence in you that we'll get this done in time. Test on Friday, and then we'll spend Monday and Tuesday of next week reviewing for the semester final, which is on Wednesday, and everything will be emailed to you. Have a great day and see you tomorrow.